हेलो बच्चों, लास्ट टाइम आपने पढ़ा था वर्क डन बाय द फोर्स एंड टुडे वी विल डिस्कस अबाउट व्हाट द रिलेशन बिटवीन वर्क डन बाय द फोर्स एंड काइनेटिक एनर्जी ऑफ द बॉडी. So let us start it. Kinetic energy of the body. Suppose a body of mass m moving with speed v. So its kinetic energy is half mv square. If I connect it with momentum, p is linear momentum m into v. So putting value of velocity, you will get p square by 2m. So kinetic energy of the body is half mv square or p square by 2m. Clear? Now relation between work done by the force and the body. If we take an example, a block is there, the force is acting on it in any direction at an angle theta. Because force is acting on it, मान लीजिए smooth surface, body will be accelerated, means its speed will change, increase in this case, so kinetic energy will increase. It means more work by the force, more kinetic energy. It means there is definitely some relation between kinetic energy and the work, and that is work done by all the forces acting on the body, work done by all the forces acting on the body, सभी का एल्जेब्रिक सम, कुछ वर्क पॉजिटिव आएंगे कुछ नेगेटिव आएंगे, सभी का एल्जेब्रिक सम सभी वर्क्स का, that will be equal to change in kinetic energy of the body. Final kinetic energy of the body minus initial kinetic energy of the body. It is work energy theorem, very important theorem. Work done by all the forces acting on the body will be change in kinetic energy of the body. Now we will discuss some examples so that this concept becomes clear to you. Let us take one example. मान लीजिए a body is moving along the surface in x direction. Suppose करिए many forces are acting on it. We are unaware of the forces, but its velocity is given v equal to a root x. मान लीजिए we start measuring its distance from O point. So as the distance x increases, its speed is increasing because many forces are acting on it. Let us find work done by all the forces when displacement is from x equal to 0 to x equal to d. इतना डिस्प्लेसमेंट हो गया बॉडी का, तो वर्क डन कैसे निकालेंगे? Forces are not given in the problem, so we cannot apply force vector dot displacement vector here. तो हमें वर्क कैसे निकालना है? इस रिलेशन से निकालना है. देखिए, वर्क डन बाय ऑल द फोर्सेज विल बी चेंज इन काइनेटिक एनर्जी ऑफ द बॉडी. क्योंकि हमें स्पीड पता है, वी कैन फाइंड आउट speed at x equal to 0 and we can find out speed at x equal to d. So we can find out easily change in kinetic energy of the body. So work can be calculated in this way. Okay. Now at x equal to 0, velocity is clearly 0, and at x equal to d, velocity becomes a root d, that is a root d, final velocity. So work done by all the forces, net work done. Net work done will be equal to हाफ एम, मान लीजिए बॉडी का मास एम है, हाफ एम वी फाइनल, इट इज ए रूट डी होल स्क्वायर माइनस हाफ एम जीरो स्क्वायर. सो दिस विल बी इक्वल टू एम इंटू ए स्क्वायर इंटू डी डिवाइडेड बाय 2. दैट इज द जो भी यूनिट आएगी एसआई यूनिट द वर्क. क्लियर? Let us solve one problem based on this concept. मान लीजिए a body of mass small m is falling down under gravity from the height h. Just before reaching the ground, इसकी स्पीड कितनी होना चाहिए? अगर मैं ग्रेविटी को एयर रेजिस्टेंस को नेगलेक्ट कर दूं तो कितना आना चाहिए? √2gh. इतनी आनी चाहिए थी if air resistance is neglected. मान लीजिए ये स्पीड इससे कम है, तो क्यों हो गई कम? ये नेगेटिव वर्क इज डन बाय समथिंग एल्स. हु इज डूइंग नेगेटिव वर्क? एयर रेजिस्टेंस इज डूइंग नेगेटिव वर्क हियर. तो मान लीजिए ये स्पीड है रूट ऑफ एन जी एच. यहां पर एन की वैल्यू लेस देन 2 है मान लीजिए. ठीक है, अगर एन की वैल्यू 2 होगी तो नो लॉस ऑफ एनर्जी, नो एयर रेजिस्टेंस. नाउ एन इज लेस देन 2 here. Now the question is, find the work done by the air friction. Work done by air friction. Okay. Now think about the forces acting on the body. One is weight of the body. Second is air resistance by the atmosphere, that is F suppose. The question is work done by the air friction. What is the value of air friction? We don't know about it. What is the value of mg? It is clear. What is final velocity? ये भी given है, but force के बारे में नहीं पता. Even then we can find out work done by this force. How? By applying work energy theorem. It's a very important theorem. From position A to B, ये कैलकुलेट करते हैं टोटल नेट वर्क डन बाय ऑल द फोर्सेस. तो वर्क डन बाय mg प्लस वर्क डन बाय एयर फ्रिक्शन, और कोई फोर्स नहीं है. This will be equal to final kinetic energy minus initial kinetic energy of the body. Work done by mg. Mg is working downwards. Displacement is downward. ये हाइट पूरी कितनी ली है बच्चों? h. Clear? Okay. Work done by mg is mg into h into cos 0, पॉजिटिव आएगा. Displacement downward, force is downward. Work done by friction, we have to calculate. We don't write anything here. So this is equal to final kinetic energy of the body, half m v final square, that is n into g into h. Minus initial is 0 because body is released from rest. So work done by friction, air friction will be mgh by 2 into n minus mgh. If you simplify it, work done by air friction will be mgh is common, divided by 2, so it is n minus 2. Clear? Now I have taken n less than 2. It means work done by F is negative, which is also clear from the direction. F is acting vertically up, displacement is down, so work will be negative. ओके तो ये था एक एप्लीकेशन वर्क एनर्जी थ्योरम के ऊपर. फोर्स हमें नहीं पता, इट मे बी चेंजिंग विद स्पीड ऑल्सो, बट वर्क डन बाय इट फ्रॉम इनिशियल टू फाइनल पोजिशन वी हैव कैलकुलेटेड. क्लियर? ओके, लेट अस मूव टू नेक्स्ट प्रॉब्लम. एक और क्वेश्चन सॉल्व करते हैं बेस्ड ऑन दिस कंसेप्ट. वर्क एनर्जी थ्योरम इज वैलिड in non-inertial frame also. Let us take one example of non-inertial frame. Suppose it is a smooth sphere, block is placed there of mass small m. It is accelerated this side with the acceleration a naught. So clearly small m block will slip this side. Now question is, when it slips, suppose करिए इस पोजीशन पर आ जाता है, at that position हमें निकालना है velocity of the block with respect to sphere. ठीक है बच्चों, यहां इसकी जो वेलोसिटी होगी विद रेस्पेक्ट टू दैट स्फीयर, नॉट विद रेस्पेक्ट टू ग्राउंड बट विद रेस्पेक्ट टू द स्फीयर निकालनी है आपको. सो वी विल स्टडी मोशन ऑफ दिस बॉडी इन द रेफरेंस फ्रेम ऑफ दिस एक्सेलरेटेड स्फीयर. सो विद रेस्पेक्ट टू एक्सेलरेटेड स्फीयर, the frame will be non-inertial. This will be non-inertial frame. Pseudo force will act. मान लीजिए with respect to the sphere we study the motion of the body. Point मान लेता हूँ बॉडी को. It come to that position. फोर्स अप्लाई करिए, mg is acting here, नॉर्मल रिएक्शन इज दिस साइड. और कौन सा फोर्स लगेगा? इट इज नॉन इनर्शियल फ्रेम, स्यूडो फोर्स विल एक्ट दिस साइड, m into a naught. Displacement of the body with respect to the sphere is vertically go this one plus this one. ये आया. मान लीजिए स्फीयर ऑफ द रेडियस ऑफ द स्फीयर बी आर, so that displacement will be r1 minus cos theta, and that displacement will be r sin theta. Clear? Okay, so three forces are acting: normal reaction, mg and ma. If my aim is to find velocity of the body, यहाँ मैंने पॉइंट मान लिया इसको, वी आर निकालना है यहाँ पर. we have to find out VR. So let us calculate work done by all the forces and put that algebraic sum of all the works equal to change in kinetic energy of the body, applying work energy theorem here. So clearly normal reaction is always perpendicular to the velocity. So work done by normal reaction will be 0. It is always perpendicular to the motion of the body. Normal is along the radius, velocity along the tangent, so it is 0. Work done by mg is constant force here. Ma naught is also constant force here, that is pseudo force. That is pseudo force. Clear? To work done by mg here. Work done by mg will be equal to mg into net displacement. डिस्प्लेसमेंट का एक कंपोनेंट इधर एक इधर है. वर्क डन बाय mg will be 0 for the horizontal component because mg and horizontal के बीच में एंगल 90 डिग्री. Then vertical displacement downward, mg is also downward, so work done will be positive, and that displacement is r1 minus cos theta. Clear? ये आ गया work done by mg for this position, for this situation. Similarly work done by ma naught. Work done by ma naught is equal to, there is also constant force. So work done by ma naught will be 0 for that displacement. Displacement vector ऐसे आएगा, this vector plus this vector. तो वो जो vertical displacement है, for that displacement work done by ma naught will be 0, and displacement in horizontal is r sin theta. Ma naught is also in that direction, so work done will be positive. So force into r sin theta, you work done by ma naught. So net work done is algebraic sum of all the works. So net work done equal to m into g into r 1 minus cos theta plus m into a naught into r sin theta. Clear? ये किसका इक्वल आएगा? In this frame of reference, final kinetic energy minus initial kinetic energy. Clear? Okay, इसको किसके इक्वल रखेंगे बच्चों? We will put it equal to change in kinetic energy of the body. Initially its speed is 0, or finally half m vr square. So this will be equal to half m v relative square minus 0. So m is cancelled. If you simplify it, so vr equal to root of 2 into r common into g1 minus cos theta. M is cancelled, r is common, g1 minus cos theta plus a naught into sin theta. That is the speed of the block at position theta with respect to sphere. So we apply the concept work energy theorem. Clear बच्चों? देखिए. Okay, समझ आया ना? गुड, वेरी गुड. लेट अस मूव टू नेक्स्ट प्रॉब्लम नाउ. मान लीजिए फिक्स्ड पुली, स्मूथ पुली, एक ब्लॉक इधर, it is movable pulley, M1 block, M2 block, it is movable pulley, string is light and inextensible, tension in the string will be like this. Clear? If I take if you apply forces here, M2G, M1G, in equilibrium, अगर मैं सोचूं इक्विलिब्रियम, M2G किसके इक्वल आएगा? दैट विल बी इक्वल टू T, और 2T किसके इक्वल आएगा? M1G. T की वैल्यू रख दीजिए यहाँ पे. 2M2G इक्वल टू M1G. सो क्लियरली M1 equal to 2M2. If M1 is equal to 2M2, system will be in equilibrium. Now, if M1 is greater than 2M2, M1 is greater than 2M2, then definitely it will come down, it will go up. Let us apply work energy theorem in this problem. Suppose this block come down by distance d, तो बच्चों बताइए कितना ऊपर जाएगा? मान लीजिए d डिस्टेंस नीचे आता है, तो बाय द कांस्टेंट रिलेशन जो आपने स्टडी किए हैं, बताइए कितना ऊपर जाएगा M2 ब्लॉक? M2 ब्लॉक विल गो अप बाय 2D. अगर ये ब्लॉक D नीचे जाता है तो इसे 2D जाना होगा, जिससे कांस्टेंट रिलेशन, लेंथ ऑफ द स्ट्रिंग रिमेन्स कांस्टेंट. सो बाय दिस कांस्टेंट रिलेशन इट हैज टू मूव बाय 2D. अगर मैं इसकी स्पीड v ले लूँ, यहाँ पर v0 मान लीजिए, तो इसकी स्पीड होगी यहाँ पर 2v0. क्लियर? वर्क एनर्जी थ्योरम अप्लाई करिए इसके ऊपर. नेट वर्क डन बाय टेंशन प्लस वर्क डन बाय ग्रेविटी इक्वल टू work done by tension will be T into 2D. T is up, displacement is up, पॉजिटिव आएगा. वर्क ना ग्रेविटी, M2G नीचे, डिस्प्लेसमेंट अप, नेगेटिव आएगा वर्क, माइनस M2G into 2D. It is net work done on M2 block by the forces. This will be equal to change in kinetic energy of the M2 block according to this theorem. We are applying work energy theorem individually on each block. So this will be T into 2D minus M2 into G into 2D equal to half m2 into 2v0 square minus 0. Clear? So you can write it 2d t minus m2g, this is equal to 2m2 into v0 square. Let this is equation number 1. Now for second block, m1 block, let us calculate work done by tension plus work done by gravity. That will be equal to work done by tension, negative आएगा, tension is upward, displacement is downward, so this will be minus 2t into d. Work done by m1g will be positive m1g downward, displacement is also downward, so that is m1g into d. So applying work energy theorem on this block, लगाओ बच्चों क्या आएगा? Final kinetic energy minus initial. Good. So that is equal to minus 2t into d plus m1g into d equal to final kinetic energy minus initial. That is half small m v0 square minus 0. So that will be equal to, suppose d is common, so minus 2t plus m1g, this is equal to, it is m1 here, half m1 into v0 square. Clear? Okay. To find speed of each block, solving equation 1 and 2, if you add them, the 2d into t, d into minus 2t, that will be negative. Adding 1 and 2, we will get the relation. It is m1 into d into g minus 2m2 into g into d. Clear? D into g is common, so that will be equal to half v0 square is common, that is m1 plus four m2, because half is common, half m1 v0 square, so 4 m2 v0 square. So you can calculate v0 from here. V0 will be equal to 2 times g into d m1 minus 2m2 divided by m1 plus 4m2. Clear? It is speed of this block, इसकी speed इसकी double आएगी. So in this way, by individually applying work energy theorem, we have calculated speed of individual bodies. Clear? Okay.